In today's lesson, we are going to look at compound parallelograms. If you think back to elementary school and you talked about compound words, that just means two or more words put together. And so compound parallelograms are two or more parallelograms put together within one figure or shape. So we're going to take a look at this one here, and it tells me over to the right hand side that JKLM is a rectangle and DKNJ is a rhombus, and we're supposed to find all angle measures. So here's JKLM, so here's our rectangle at the bottom, and OKNJ, this shape up here, is our rhombus. And the one thing that we have marked is 32 degrees right here at angle PKN at this portion here. So in a rhombus, I know that the diagonals bisect the angles. So if this piece is 32 degrees, then this piece up here will also be 32 degrees. And I also know in a rhombus that opposite angles are congruent. So if these two are 32s, then all the way over here at J, these will also be 32s. I also know in a rhombus that the diagonals are perpendicular. So I know I have 4 right angles made right there in the center of the rhombus. Now I'm actually almost done with the rhombus at this point. I really just have these angles, and I can get those in a couple of different ways, so let me just kind of talk through both of them for you. This entire angle of the rhombus over here, I would add these two together and I would get 64 degrees. And then this angle and this one are going to add up to 180. So I can know what that whole angle is up there by doing 180 minus 64. So let's see, 180 minus 60 would be 120, and 120 minus 4 would be 116 degrees. Now that's all of angle O up there. This diagonal is supposed to bisect that or cut it in half. So half of 116 would be 58 degrees, and that's going to be the same on both sides since the diagonal bisects the angle. Now the other way we could have gotten that is I could have looked at triangle OPK and said all triangles always measure 180 degrees, so 180 minus 90 minus 32 still gives us 58. So we could have come up with that 58 either of those two ways. Now in a rhombus, if angle O up here is 116, then this angle down here, JNK, would also be 116, and so that would be 58 and 58 since the diagonals bisect the angles in a rhombus. Now the diagonals do not bisect the angles of a rectangle, so it's not like 32 and 32 over here. What we know about a rectangle is that the angles are always 90 degrees. So if angle PKL is 90 degrees, and this piece of it is 32, then if we do 90 minus 32, we should be able to find the number that goes right here. So 90 minus 30 would be 60. 60 minus 2 would be 58 degrees. Now, we also talked about the other day that in a rectangle, all 4 of those pieces of the diagonals end up being congruent. That means that triangle KNL is an isosceles triangle, and in an isosceles triangle the base angles will be congruent. So across from this side is 58, across from this side should also be 58. Now this is still a 90-degree angle, so 90 minus 58 should give me 32. Now I have another isosceles triangle. Across from this is 32, across from the other congruent side should be another 32. This is yet another 90-degree angle, so 90 minus 32 gives us 58. 58 should be the two base angles, or I could again use that 90-degree angle over here, and we get 58. So we're in really good shape at this point. The only labels we need left are right here at N. There's all kinds of angles at N happening, so you'd have to name them with 3 letters, of course. Let's do this one right here, KNL, so this angle. This angle is going to make a straight line, JNL, this long line right here, is a straight line, and straight lines measure 180. So if I do 180 minus 58 minus 58, then what remains here should be the measure of this angle, and we're going to do 180 minus 58, or 180 minus 116. So 180 minus 110, that'd be 70. 70 minus 6 would be 64 degrees. Now because this is 64 degrees, its vertical angle partner over here will be 64 degrees. And down here, we know that this line is straight or this line is straight, so we can do 180 minus 64, and we should get 116 degrees. And we have every angle labeled now in that compound parallelogram. Now let's look at this one. We are told here that ABCD is a square and ACEF is a square, and we're supposed to find all angle measures. And you will notice there is nothing at all written in here as far as an angle measure goes. That's okay, because we know everything we need to know about squares. Remember, they are the most specific type of quadrilateral that exists. We know in a square that every corner is 90 degrees. And because it is also a rhombus, we know all 4 angles here at D are going to be 90 degrees. We also know that in a rhombus, the diagonals bisect the angles. So here I have a 90-degree angle, but it is being bisected. So that means it's going to be cut in half to 45 and 45. And that's going to happen in every single corner of our square, because every time a 90-degree angle is being cut in half. We're almost there. This ABCD is also a square, so this is also a 90-degree angle here. If that part's 45, this part's 45. And the same thing happens here. So we end up with a whole bunch of 45-degree angles, other than when we have a plane corner that's not being bisected, or where the diagonals intersect. We know those are going to be 90-degree angles. We have one more shape to look at. Here we are told that EFGH is a rhombus and FKLM is a rectangle, and we're supposed to find all angle measures. So you'll notice not quite as much is drawn in this time. We have a lot of stuff in our rhombus. The angle measure is out here, which happens to actually occur in the rectangle itself. So the rectangle is FKLH. So I know that this right here needs to be a 90-degree angle, and 50 degrees of it is down here, so that means this piece must be 40 degrees. And in a rhombus, the diagonals bisect the angles, so this angle would also be 40 degrees. That means way up here at angle F, that's going to happen again, 40 and 40. And I also know that the diagonals are perpendicular, so we've got a bunch of 90-degree angles there at J. Now, if angle F, as I'm just talking rhombus, if angle F is 80 degrees, then angle E has to be 100 degrees. Because remember, these two have to add to 180 since they're in a row or consecutive. So this 100 degrees at angle E is going to get cut in half with our diagonal, so we've got 50 degrees. And that's going to happen over here then at G as well. And we're almost done. We have a corner over here at L that we know is 90 degrees, a corner over here at K that we know is 90 degrees, and this corner at F is 90 degrees, but 40 degrees of it is there, so 50 degrees of it will be over here. And we have everything labeled. Today you're going to be taking a look at some compound parallelograms, labeling a bunch of angles within those, and even some side lengths as well. Based on the information that you know about which sides are congruent and the diagonals bisecting each other. Then there's also going to be a section where you have each of the 3 special parallelograms, and you simply have to label every angle measure that you have remaining in the figure. So refer back to this as much as you need to help figure out how we got some of those angle measures. Use your properties for each of the special parallelograms. If you haven't already, you might want to print out a copy of one of those check charts that you could find online. Anything that you could have that would help you visually organize your information would probably be helpful. Anyway, if you have any questions, of course, as always, let me know.